What you up to, Mr. Kyle?
Oh, sorting rocks. Are we still doing rocks, Miss Reinfelder? You know, I like rocks. The science is cool, but they are still just kind of rocks.
Yeah.
Is there anything more interesting about them?
Well, you know, some really cool things can be found when you start splitting rocks open. Do you know what we find inside rocks?
No, what do you mean?
Well, we can find stories inside rocks.
There's stories inside rocks?
Yeah. Inside rocks, there are fossils which tell the story of our Earth as far back as 4 billion years ago. The scientists that study this fossil record are called paleontologists. And it's not all about dinosaurs, Mr. Kyle.
Hey, but I like dinosaurs.
I love dinosaurs, but paleontology has to do anything that was once living or the stuff around the thing that was once living. So it's animals and dinosaurs and plants and even nests and hoops and all of these things stored in the fossil record, which let us know what animals used to look like that no longer exist and how they even lived their lives.
Let's learn more about fossils.
Oh my gosh, Miss Reinfelder, you're so right. The more that I looked into fossils, the more interesting it got. Fossils are like a photo or a snapshot taken of what the Earth was like millions and millions of years ago. It's so amazing. Did you know that there are 2 kinds of fossils? The first kind is called a body fossil. And of course, it's a fossil of a body. And it not just like an animal body, but it can also include plant body. I have some body fossils right here. This is not a real fossil because they wouldn't let me hold a real fossil. It's a replica of a fossil of a T-Rex's tooth. That's huge.
Wow.
Imagine. That's a big tooth. And we have another one right here. This is a T-Rex claw. Could you imagine trying to clip these toenails every month? A
Yeah.
week? How often are you supposed to clip toenails?
Mr. Kyle.
I got sidetracked. There are some more cool fossils too. This one I actually saw revealed. A friend of ours came to the lab and he was like, I bet you there's a fossil in this rock, and the rock was like this thick. And he took a little nail and a hammer and chiseled a hole on the side, and it split open, and look at that.
Whoa, so cool.
A leaf fossil right in there, which is a type of body fossil. We also have things like this petrified wood, which used to be a tree.
Oh yeah, you can still really see the wood grain in it.
Yep.
Cool.
And then another thing we have is this ammonite fossil, which is an ancient sea creature. This guy was from Madagascar 110 million years ago.
Wow, that's so cool, Mr. Kyle.
I know.
The second type of fossil is trace fossils. These are fossils that aren't animals themselves, but things that were around the animal or were left by the animal. So it could be a nest or tracks or even dinosaur poop. We have a coprolite, which is the scientific name for poop that has been fossilized. This is a tortoise poop from Madagascar that is 50 million years old. It no longer feels like poop or smells like poop, and certainly doesn't, I'm just kidding, taste like poop. But yeah, so I found that really cool. If we go out and compare this to the tortoise poops outside, it literally looks like the same exact thing. See, here we are out at the tortoise habitat. Louis, our big tortoise, he hasn't changed much in 50 million years, and here's our coprolite. Tortoise poops haven't changed much in 50 million years. Wow!
Fossils are usually left by plants or animals that had died, but not every plant or animal becomes a fossil. Taxonomy is the study of what happens to a body after it dies. Most of the time when something dies, its body decays and turns back into soil. And in order to become a fossil, conditions have to be just right. There are a couple of different ways we study and learn about these remains. Number one is altered remains, which is like a photograph of what happened or that thing that was there. A lot of our fossils are altered remains. This is not the actual thing or plant or animal, but it is a replacement of that animal. And then other things are called unaltered remains, which are that exact thing stuck just how they were. Number one, you can have like an insect stuck in amber that got fossilized. Amber is fossilized tree sap. And another example is a mammoth. This is a picture of a baby mammoth that was frozen in north of Russia, and they just found it in the ice a few years ago. And it's actually so well preserved that they could actually get DNA out of it.
Wow, Mr. Kyle. Is that the one they're talking about? Possibly using that DNA to bring the mammoth back using elephants?
Yeah, they're talking about cloning mammoths using elephants or interbreeding the DNA together. I'm not smart enough to really know how that works, but because it has viable living DNA, we think we could use this DNA to bring mammoths back from extinction.
Wow, that's so cool.
I know.
Like Mr. Kyle was saying, in order for fossilization to occur, there usually has to be a quick event of some sort. In other words, like Pompeii, where the lava flowed over the town. That was a fast event. It covered the entire town rapidly. We have lots of fossilized remains that help tell the story of what was going on in that town on that particular day when that lava flow happened. Most animals are going to fall into sediment. That's why when we were talking about rocks, we were talking about sedimentary rocks, that layered rock. And that is where most of our fossils have come from. And the way that happens is through a process called permineralization. And permineralization, the animal falls into mud or sand or to a river or sea bottom, and then the silt covers up that body and presses down over time. Eventually, that body is permeated by mineralized water. And just like we were talking about last week with geodes, when that mineralized water permeates, that's where the word comes from, permeating, mineralization, permeates that body, it can either fill it or replace it with that mineralized past. Just like when we were looking at this little ammonite, it is a solid rock now. Its body was replaced by these minerals that seeped in and made it a permanent mineral replica of the animal that once existed.
Wow, so fossils really are just like pictures. Like a picture isn't really you, but it is a picture of what you were doing or looked like at that time.
Yes, exactly.
Wow, Miss Reinfelder, that's amazing. I learned that fossils are actually very, very, very rare. They account for less than 5% of the species of animals and plants that were actually alive at that time. So all the things that we know of that lived a long time ago, like woolly mammoths and saber-toothed tigers and T-Rexes, those only account for a very small portion of animals and plants that were alive at that time. Could you even imagine what was real? And oh, it would be so amazing. Because fossils are so rare, our fossil record only shows a small portion of what was there. And we've had a hard time trying to piece together all of the human-like creatures called hominids that used to be around. We know that there's more than 5, but 5 that I know of pretty well. An interesting fact that I heard a while ago was that however many people on Earth, it's like 7 billion, right, Miss Reinfelder?
Yeah.
A good amount of people. If some kind of event were to happen that wiped out all the people on our planet, how many people would turn into fossils, do you guys think? million, a billion, half of that, it actually turns out that only 2 human fossils would be found. 2 full human fossils. And if you think about all the like T-Rex fossils that we've seen and all of those saber-toothed tiger fossils that we found, imagine how many of these guys there were back then.
Wow, that's such an amazing fact, Mr. Kyle. Matter of fact, there's a super interesting place to visit in Los Angeles, and it's like right in the middle of the city where they've got a really great snapshot of Ice Age fossils. It's the La Brea Tar Pits. I put a video link down below for the La Brea Tar Pits. It's a really cool place to visit if you happen to be going through town, and they had tons of mammoth fossils, saber-toothed tigers, dire wolves, giant sloths, all that fell into these tar pits, which are the perfect conditions for forming a fossil. The animal dies quickly and is covered for millions of years down in, or hundreds of thousands of years down in these tar pits. And they've been able to dig out these skeletons and piece them back together and really put together a cool picture, a cool snapshot of the Ice Age.
Wow, Miss Reinfelder, fossils can be so interesting.
Yeah, they really are, like little secrets hidden in rocks.
It's like finding buried treasure learning about fossils.
It is, it is. Well, in class this week, we were making some of our own fossils, and if you have these materials at home, you are welcome to try this craft out with us. All right, so to do this craft at home, you need a paper plate. And the first thing you're going to do is write your name on the paper plate. If you're home and you're alone, maybe you don't need to write your name because you won't have to tell anybody else's. Second, you're going to paint the whole inner surface with glue. Nice thick layer. Then put a few leaves or pine needles or other things you find on the ground in your glue. Probably no rocks. We don't want big and lumpy. And then we took some wire and made some shapes that would look like fossils, and you could go for like the Nautilus shape or little dead fish shape or dinosaur track shape, whatever shape you want to. You can do this out of an old metal hanger or any other bendable wire that you might have around the house. Then you're going to take a sheet of tissue paper and you're going to press it across all of the items you've put in your glue and smooth it out, and then add another layer of glue, nice and thick across it. Then you're going to add a second layer of tissue paper over the top and a second layer of glue. Then finally a third layer of tissue paper and a third layer of glue. Not fourth, third layer of glue. And you want that last layer of glue to be really complete, because if you just dab glue here and there, the tissue paper won't be see-through like it is in this example. And we want to be able to see all of our specimens through that third layer of tissue paper and glue. At this point, you're going to stop and let it dry for 1 or 2 days, because you've got all those thick layers of glue. It might take more than 1 day. When it is completely dry, take pastels or sidewalk chalk in earth colors like yellow, orange, brown, black, and just scribble real quick across the surface of all of your items. Then you take a paintbrush, a good stiff one, or a piece of paper towel and rub it across your chalk or pastels, and it will give you that kind of natural rock-like appearance. We went ahead and cut ours out. Afterwards, you can leave it on the whole plate, but we liked the look better when we cut it out, and voila! There is our craft project of a fossil. I hope you enjoyed it. You can also press shells or plastic dinosaurs into Play-Doh at home, or make some dough in the kitchen, make some salt dough and practice making impressions in your dough with items you have around the house. That's a ton of fun. We learned the hard way with preschool this year that if you're pressing into dough or Play-Doh, you might want to spray those items with cooking spray before you do it. Otherwise, the dough can really stick to them and it can be hard to clean up. Huh, Mr. Kyle?
Yeah.
Yeah.